Welcome to this video about my journey to date with AI tools and the useful AI applications I've explored, particularly in education. I'm Curtis Beaverford, a professor at Tamagawa University, specializing in curriculum design and assessment. With 30 years of global experience, my current work focuses on integrating AI into teacher education and designing AI-supported learning environments. I've found AI tools that remove barriers to learning and increase access. These include tools for translanguaging, multilingual explanations, differentiated reading levels, converting text to audio/video, and GRASP's analysis for assessment expectations. Translanguaging is a teaching approach that encourages students to use their strongest language for part or all of an assignment. In the past, this was difficult to implement, especially for monolingual teachers. AI now makes translanguaging more accessible. Rather than simply translating, AI rewrites text while preserving the original tone and intent. This allows students to conduct research in the academic language they know best. Tools like Zoom's simultaneous translation with captions support this process in real time. Converting text into audio and video is another powerful feature. Google Vids makes it easy to script instructional videos, which are especially useful because they can be quickly edited and reused. You can turn slide decks into narrated videos, create scripted presentations delivered by AI avatars with accurate lip syncing, and more. The interface is similar to other Google Workspace tools, making it easy to learn and use. Notebook LM allows you to convert text into video explainers or podcasts, using either entire corpora or individual resources uploaded to your space. These explainers can be created in any language. The audio overviews are interactive. Students can interrupt the presenters to ask questions about the material. Currently, responses are only available in English, but students can ask questions in any language. A GRASP's analysis is a framework used to design performance tasks that clearly communicate assessment expectations. It stands for goal, role, audience, situation, product/performance, and standards, helping teachers create authentic, real-world assignments that align with learning objectives. While writing a GRASP's task can be time-consuming, AI can significantly speed up the process. By inputting your assignment description, AI can generate a well-structured GRASP's task that clearly communicates what students are expected to do. As long as you carefully review and edit the final version, AI can help ensure your assessments are both authentic and clearly understood by students. Differentiating instruction based on language proficiency is now faster and easier than ever. AI tools can quickly rewrite content to match different reading levels, accurately applying the necessary linguistic rules. What once took hours now takes only seconds. Differentiated instruction is essential for ensuring that all students, regardless of their language ability, can access and engage with the material. By adapting content to meet diverse needs, teachers can support equitable learning and help every student succeed. AI also strengthens assessment literacy and reduces teacher workload. One approach I have been exploring is the use of custom GPTs trained on specific rubrics to generate targeted feedback for students. By aligning the model with the assessment criteria, the GPT can provide consistent, criterion-based comments, highlight strengths and gaps, and point students toward the next steps in their learning. This makes feedback faster to produce, more reliable, and easier for students to act on. Custom GPTs rely only on the sources you provide, making them highly reliable for targeted tasks. I've built several for my courses to give students instant, criterion-aligned feedback, which has noticeably improved their work. Students get support exactly when they need it, something hard to manage in large classes, and the analytics show they use these tools frequently and with strong engagement. For the personal project, I created a feedback engine trained on criteria, student work, and assessed projects. Students can feed their work into it for instant feedback and see examples of how others have met the criteria. For the extended essay project, students use an AI tool log to paste their conversations with the AI. This not only provides evidence of authorship, but also allows them to receive feedback on their prompt engineering skills. There are key differences between AI tools like Notebook LM and custom GPTs. For example, in Notebook LM, if you want the tool to engage with an entire project, you must upload the file as a source rather than simply attaching it. While Notebook LM can offer useful feedback, it can be more difficult to keep it focused strictly on the sources provided. In contrast, a custom GPT can directly interact with uploaded documents and respond in ways tailored to your instructions, making it more reliable for consistent, source-based academic support. AI helps both students and teachers process complex information more efficiently. Its applications include supporting research, comparing sources, summarizing academic texts, reverse engineering arguments or tasks, and analyzing student work samples for patterns and learning gaps. Scholar GPT is my preferred tool for research, trained exclusively on peer-reviewed academic papers. It reliably sums up author works, reviews materials, and assists with reverse engineering. AI-enabled browsers like Perplexity's Comet and OpenAI's Atlas are valuable tools during lectures. They allow for real-time fact-checking, validation of claims, and offer powerful features for augmented research and knowledge mapping. I always have one open when working with students modeling how these tools can be used for research and knowledge mapping. Training chatbots on limited sources reduces errors and hallucinations. I created custom GPTs for my students, using both OpenAI ChatGPT and NotebookLM versions trained on the same documents. AI excels at converting material into various learner-friendly formats, including summaries, AI-generated textbooks, interactive learning spaces, infographics, and podcasts. NotebookLM is a powerful tool for transforming content and generating materials. It lets you build an interactive textbook from curated sources. Students can chat with it, listen to audio overviews, or watch video explainers. Analytics show high student engagement. Its effectiveness depends on thoughtful source selection. Too many sources can overwhelm the tool and reduce clarity. It's best to include only key materials that directly support your learning goals. You can also give specific instructions when creating explainers. For example, I upload my lecture slides and tell it to focus on them, using other resources only for examples and clarification. This keeps the output aligned with my teaching while enhancing student understanding. I particularly appreciate the video explainers generated by these tools. They effectively clarify complex concepts and can be created in any language. In addition to video explainers, NotebookLM can generate interactive audio overviews, slide decks, quizzes, flashcards, and infographics using either a single source or an entire collection of materials. One space I've personally found useful is trained on the complete works of John Dewey and William Shakespeare. NotebookLM also allows users to share the spaces they create. So if you don't want to build your own, you can often find a ready-made space that suits your needs. AI is especially powerful when built into tools learners already use, like Google Docs, Zoom, Padlet, and AI-enabled browsers such as Atlas and Comet. Atlas can even take over your browser to handle time-consuming tasks like reformatting or filling out forms. Gemini can translate text inside a Google Doc and place it exactly where it belongs, supporting multilingual collaboration. Many of these tools also generate high-quality images that drop directly into documents or slides. Every graphic in this presentation was made by Atlas, which read the text on each slide and generated an image to match, saving me hours of searching for usable stock art. AI is also an invaluable partner in the planning process. I work with teachers to design unit, year, and program-level planning documents, and AI tools make this work far more efficient. In this example, we sketched out an entire Grade 2 program of inquiry using the Australian curriculum. Atlas analyzed the curriculum, suggested how subject objectives could be grouped into 6 units of inquiry, and identified what would need to be taught as standalone content. You still have to refine and adjust the results, but the initial framework it produces is surprisingly strong and gives teams a solid starting point. Tools like Atlas help review and update instructional materials quickly. They flag outdated content, suggest revisions, and streamline routine editing so resources stay current and consistent. Atlas can even apply changes automatically, though I still review its suggestions to ensure they align with my intentions. Even so, it's already a reliable partner for keeping materials up to date. In my online classes, Zoom's simultaneous translation lets students speak in their strongest language while others read subtitles. It has made discussions more inclusive and fluent. Zoom also generates a class summary, which I run through GPT to translate into the languages in the group so everyone leaves with clear, accessible notes. You might find these resources interesting. Links to my NotebookLM spaces, my course podcasts, the custom GPT feedback engines I created, and our Twitter feed. I hope you found this useful. Thanks for watching,